Hey everyone, welcome. So if you're laser focused on truly mastering Google Cloud, well, you've landed in the exact right spot. Today, we're taking typical certification prep and flipping it into something way more valuable. Think of this explainer as your practical, day one, on-the-job playbook for managing virtual machines. I am super excited to guide you through this, because we're not just, memorizing dry facts here. We're going to learn how to actually build, secure, and scale cloud infrastructure exactly like a seasoned pro would. All right, let's dive right into our battle plan. We'll kick things off with your Google Cloud Toolkit, then move into building your first VM, mastering the command line, advanced security and configs, and finally, controlling your cloud costs.
So, Section 1, your Google Cloud Toolkit.
Before we can build anything, we gotta know our tools, right? As a cloud engineer, you essentially have three main ways to get stuff done. First up, the Cloud Console. This is your standard web-based graphical interface, perfect for visualizing things and getting the lay of the land. But when you need to automate or just work a whole lot faster, you're going to use the Cloud SDK. That's a command line package you install locally on your own machine. And finally, we have Cloud Shell. This one's incredibly handy because it's a web-based terminal right there in your browser. And honestly, the best part? The Cloud SDK comes pre-installed in Cloud Shell, so you can literally just fire off commands right away without installing a single thing on your laptop.
Moving on to Section 2, building your first VM.
Okay, picture this. It's your first day, and you've been asked to launch a brand new virtual machine. Before you even think about hitting that Create button, you have to look at the top of your console. Are you in the right Google Cloud project? This project is your absolute foundational workspace. Seriously, verifying that you're in the correct project is step 0. I want to emphasize this heavily, because every single operation applies only to the selected project. If you skip this check, well, you might spin up expensive resources, or yikes, delete something critical in completely the wrong environment. So always check the project. Now, to actually spin up that machine, you need a specific recipe, a minimal set of ingredients. You need a name, a region, a zone, a machine type, which is what dictates your CPU and memory, and a boot disk with your operating system. And this brilliantly illustrates a super vital piece of logic you need to keep in your back pocket. If you're trying to select a specific machine type and for whatever reason, you just don't see it in the dropdown, it's almost certainly because that machine type simply isn't available in the zone you picked. The region and zone always dictate the hardware you have access to.
Let's put this into practice with a real-world scenario. Imagine you're working with a team of data scientists. They need a 10-gigabyte data set sitting right there on the local file system of their new VMs to run our programs. And of course, they want to minimize their setup steps. So, how do you deploy this efficiently?
The absolute most efficient way to handle this is by creating the VMs using a custom source image. Basically, you load that 10 gigs of data onto a disk, create an image out of that disk, and then specify that exact source image when you're building their VMs. This completely eliminates the need for those data scientists to manually copy data over from cloud storage every single time they need a new machine. Honestly, it saves a ton of time, and hey, it makes you look like a total hero to the team.
All right, Section 3, mastering the command line.
So clicking through the console is fantastic when you're first learning, but let's talk about why the command line is an absolute game changer. Consider this massive headache. You're leading a team managing cloud resources across multiple departments, and you start noticing configuration drift. Machines just aren't in the same state they were when you created them, and worse, there is zero documentation explaining who clicked what or why they did it. How on earth do you stop this?
You stop it with automation. You step away from those manual console clicks. And instead, you write scripts using gcloud commands to make your configuration changes. Then, and this is key, you store those scripts in a version control system. This is a massive pro tip right here. Scripts are precise, they are completely repeatable, and version control gives you an ironclad history of exactly what was changed and when. It guarantees absolute consistency across your whole setup.
Now, what's really interesting about this slide is that the command line actually becomes incredibly simple once you grasp its internal logic. You absolutely do not need to blindly memorize long strings of text. The Cloud SDK uses this beautifully strict hierarchy. It always kicks off with the top-level command, gcloud. Next up is the service you're targeting, something like compute. Then comes the specific resource type, like instances. And finally, you give it a verb, an action to perform, like create, list, or stop.
Let's see how this actually translates into a real working command. Say we want to spin up a web server with 4 CPUs. We'd start with gcloud compute instances create. Then we toss in a parameter, --machine-type equals n1 standard 4, and pass the argument for our server's name. Let's say web server 1.
By internalizing this whole G-Cloud, then service, then resource, then verb structure, you'll be able to confidently write commands for pretty much anything inside Google Cloud.
Moving right along to Section 4, Advanced Security and Configs.
So once you've nailed down building and scripting your infrastructure, you've got to know how to lock it down and protect it. If you're standing up a server that needs top-tier security, you absolutely need to know about shielded VMs. This is a crucial feature. Opting for a shielded VM applies this advanced set of security controls, specifically something called integrity monitoring. This essentially keeps a constant watch to ensure your operating system's boot image hasn't been tampered with, which is exactly what protects your servers from those really nasty rootkit malware attacks.
Another huge part of optimizing your environment is simply knowing what type of machine to run in the first place. Standard VMs are exactly what they sound like. They give you consistent, reliable uptime at a standard price. But if you're dealing with flexible workloads, you really need to understand spot VMs, which used to be called preemptible VMs. These are incredibly cost-effective, but there's a catch, a major operational trade-off. Google can, and totally will, shut them down within 24 hours of starting them up.
And that brings us to Section 5, controlling your cloud costs. 80%. That is a massive number. When your workloads are fault-tolerant and can actually handle a sudden interruption, utilizing those spot VMs we just talked about can save your company up to 80% compared to standard VMs. And let me tell you, finding those kinds of massive cost optimizations, that is exactly the kind of thing that gets a cloud engineer promoted.
You also really need to understand exactly how the meter runs in the cloud. Over in Google Cloud, VMs are billed by the second, though there is a minimum charge of 1 minute. But because you're billed per second, your final bill is insanely sensitive to your exact CPU count, your memory, and the precise runtime of your workloads. Literally, shutting down a machine the exact second a compute job finishes translates directly into real money saved.
And of course, with costs comes accountability. Here's a classic business problem you are almost guaranteed to face. Your team is running dozens of shared resources, right? Then your manager walks over and says they need a way to separately bill the marketing department and the finance department for their specific VMs. So how do you actually separate that out?
The hands-down definitive answer here is labels. Labels and descriptions are these absolutely crucial attributes that you attach directly to your resources. When your environment scales up to hundreds of VMs, tracking costs manually becomes literally impossible. But by applying a label like, say, Department Marketing or Department Finance, you can instantly filter your billing reports and allocate costs perfectly. It keeps your whole cloud environment just beautifully organized.
So the crucial point to remember is how to apply these systematically. When you're writing those G-Cloud scripts we hyped up earlier, you want to attach your labels right at the moment of creation. You do this using the --labels flag, and it's formatted exactly as keys equals value. No colons, no commas, just keys equals value. Doing it this way ensures your billing tracking is completely automated from the very first second that virtual machine boots up.
Wow, we have covered some truly incredible ground today. You now have the fundamental playbook to select your toolkit, spin up custom VMs, utilize that command line hierarchy, lock down your OS, and dramatically slash your costs. The knowledge is officially yours. But I want to leave you with one final provocative question. You now have the toolkit to build, secure, and scale, but do you have the discipline to go out there and automate the whole shebang? Take these skills, start writing those scripts, and go build something amazing. Thank you so much for joining me for this explainer, and keep on learning.